There we go. All right, can everyone see my screen good? Perfect. All right, so this is session 3 of Coding with Cody. Today we're just going to be going over autonomous movement and functions. So we'll be talking about writing reusable movement functions, for example, driving forward and turning left without actually typing out the code to actually do that. Using timing functions, so delay versus millis, and then sequencing tasks for autonomous robot actions. So just a little starting out, what is a function? A function is basically a callable statement that will run a certain set of code. So say you want to get data from a sensor and you want to keep doing that, but you don't have to keep typing out the 10 or 20 lines of code. You can put that into a function, and then every time you call that function, which most times is 1 or 2 lines of code, it'll run that code. They're great for when you want to run a set of code more than once, but you don't have to type it all out because it makes it a whole lot neater and easier if you just see that function call instead of a whole bunch of code that you might not understand what it does later on. So there's a few applications of a function. They basically want to use them whenever you want to call a set of code in different places in a program. So for example, getting data from a sensor, or driving a robot forward a certain distance, or turning right or left. Let's see here. Yeah. And then another quick thing about functions are the timing functions. So the delay function, which is one we used in the last 2 meetings, these are just a commonly used way of making an Arduino wait before it runs the next line of code. But the issue with these is they actually block the Arduino from running other code. So for example, say you want to wait before you drive forward, but you still want to be getting data from all your sensors. If you use a delay, it won't pull that data. It'll just keep waiting. Millis is a different way of getting timing for an Arduino. So millis just returns the time in milliseconds that the Arduino has been running. So instead of saying delay a second to wait to the next line of code, you can make an if statement that'll check current time versus the time you stored in a variable. And then when that time becomes a second greater than the last stored time, you know that it's been a second and you continue the code. But this also allows you to have background operations going on. So another use case for functions that we're going to be talking about today is motor control. So functions can allow for motor control of ESCs without commonly using the lower level commands. So last time we talked about the silver right commands in microseconds to set the degrees, or in our case, the forward and backward proportion. So you could use a function, for example, to go forward, and that would, you just have to type out go forward, and then instead of having to type out all of the silver.right microseconds for all 4 motors. It allows for more complex movement with easier to understand code. If you just went and typed out all of the needed commands to make a robot go in a square, for example, it would be about 50 or 60 lines of code. But if you just had it in functions, it could probably just be go forward and turn, and then go forward and turn on repeat, instead of having to.
I'm in a conference and I can't hear anything.
He's coming down tomorrow by block 6.
Who?
Cooley.
Block 6?
Yeah.
For what?
So for an example, I'm gonna go ahead and just show you guys how to blink an LED with millis instead of the delay, which we used last
block
time.
6? Okay.
So I said,
Go share the screen.
yeah, he looked at has seen our lesson plans, and he said that would be a.
All right. So to use the millis function, first we're going to just define a few pins like we always do. So we'll define our LED pin as pin 2, and then we'll also have another variable to define what delay we want to run for. The delay time, we'll make that 1 second. And then down here in setup, like always, we have to go and do our pin modes. So we have LED pin and an output. And then we'll also get our serial just so we can see what's going on. 9600. All right. And now come down here into the loop. So the main thing that difference is here is instead of using delays, we have to use a millis. So first things first, we're going to want a unsigned long, which is a different type of variable. Different between this and just a normal integer is it's unsigned, meaning it doesn't know it only has positive numbers. And it's the long means it's a 64-bit number, so it's a much greater storage capacity in it. And we'll call this time since, and we'll set that to equal to 0. And then we want to type an if statement, and then if millis, which is the function that returns how long the Arduino has been running, plus delay time is greater than or equal to time since. Also go ahead and not make that 0, that's the current time. Brackets just to run the code in the if statement. It will then write digital write to the LED pin, set it high, so on. And then also going to have another quick variable up here, a bool, which is a boolean, which is an on or off. I'm going to make a bool for state of LED. I'll start that off at false. They're off. Then do some more branches here, if statements. We'll have a little more in-depth about if statements, while loops, and for loops in the next class, but all you need to know for now is an if statement essentially is it just compares the argument inside of the parentheses. So if the millis plus delay time, that's if millis plus the 1 second delay is greater than or equal to the time since, which is time that the LED was last called, we will then run the code inside of that. And now if we want to make sure it actually turns it on or off, so if the state LED is true, so since it's true, it's just an on or off, you don't have to do any arguments. We will turn it off. Then LED fan below. And we'll also turn the state LED to false. And then we'll run another if statement. Go ahead and get rid of my code. Or if it's low, so if is not equal to state LED, which the exclamation mark just means not. So if LED is not true, so false, it'll then run this code. And here we want to set the LED for on. And it would help you to the record. There we go. And then turn the state LED variable back to true, so we know the LED is currently turned on. And then we'll also go ahead and update our unsigned long here of time since to equal to millis. And just another thing, this should actually be in the setup. If we have it in the loop, it'll be updating repeatedly, and this code will never get called because it will ignore this if statement since it's not greater than time since, and it'll keep updating time since, and it'll never actually become big enough to trigger this if loop. So we'll do that, and then same thing with state LED. That should also be in the setup just to run the code once. Just format it nicely. Fix our spelling issues. And then we'll make sure it compiles here. It didn't. You look up here and see what it says. Time since. Guessing I have my let's see. Yep, we need to make these global variables. That means is we need it if a variable is inside of a void, which is a function, anything outside of that function cannot actually access it or doesn't know what it means. That's why you have to go ahead and declare them up top in the global variable section, so it'll actually know what to do with that data. There those. Thanks. Consistent. So make sure to go ahead and group those arguments. Short foot indented nicely. Now, if we try again. Now it compiles. So if we just go back over our code here, if millis plus delay time greater than time since, it'll then check the state of the LED. So if the LED is currently on, we'll turn it off. And then if the LED is currently off, we'll turn it on. And then it will, after changing the state of the LED, it will then change the time since to millis. So it'll grab the current time. That way it'll have to wait another second before it updates the state again. So now, second, I have to save it here. Reload it after it saves. Now, wait for Arduino IDE. There we go. Now we go back up tools, make sure we have the right port selected and the right kind of Arduino. In my case, I'm using Arduino Nano. Then we'll go ahead and upload the code. Ooh. Looks like somehow I typed something else. Perfect. Make sure it compiles and uploads correctly. Perfect. I'll go ahead and change cameras. So we can see the LED. 1 second. Go. And if we look at the LED, we can notice it's not ever turning off. So we go look back at our code. We can try to figure out why that is. So let's see here. I can look at my example just to double check that I know it. All right, perfect. So example. We go back through our code. Currently, it is not. First thing to check is always make sure your delay time is actually the correct value. So 1000 is 1 second. And then we're going to go ahead and double check our wiring. So LED is on pin 2. Go back to our Arduino here. It is hooked up to pin 2. Aha. Let's see. And then make sure all of our outputs are correct, and it is. Make sure those are both getting set. Then try changing 1 second. Make sure I have my logic correct. Different way of going about it just to see. That should have worked. Sure. Ah, now I have our Arduino. COM10, load that. 1 second, let me go. Make sure I don't have another window trying to override that. Go back, check our port, COM10. Should be uploading. All right, 1 second. Seems my Arduino doesn't want to work with me. Ah. What's that? Oh, all else fails. We'll unplug it and plug it back in. Sometimes Arduinos do get a little bugged and don't want to communicate. Try uploading it again. Okay, still not communicating. Well, another good thing to try when your Arduino's not working is just completely close out of the Arduino IDE and open it again. It's also a great reason to have your code saving periodically. 1 second, my Arduino IDE is unplugged. 1 second, guys. Oh, there we go. Seems like I had an instance of Arduino open that wouldn't close for writing my COM ports, but here we go. I'll have this shared in 1 second. Here's my computer will load the Arduino IDE. There we go. Open up the recent one. There we go. Now, share my screen again. All right. Then we'll go back up here, make sure all of our boards are still selected. Try uploading the code again. Hopefully it'll work this time. Load failed. Now we'll go check and make sure we have the right COM port selected. Sorry about this, guys. This is just the way Arduino programming is sometimes. Gives you errors. You have to troubleshoot through them. Let's see. Yep, that is the right COM port, COM10. COM10. You will try. Sure, everything else is open. Try opening the serial monitor and then reclosing the serial monitor. Sometimes those will get hung up a little bit. And we'll try uploading again. Aha, there we go. That fixed it. So we still have the same error we did last time of the LED is not actually blinking. So we'll try a little different logic approach, changing it to time sense is not delay time. So millis plus delay time. Well, actually, look back at mine. Just make sure I'm doing everything correctly before I tell you goes wrong. Yes. So current minus time sense. The way I had it last time. Is greater than delay time. Then we will update time sent. That's getting done in that if statement. I'm going to swap over to the code that I know works. Probably just missing something basic, but 1 second. So in this example, still have the unsigned long for our millis, and then it is just checking if current millis minus previous millis is greater than the interval, and the interval is 1000 milliseconds. And then it sets the previous millis to equal current millis, and then it'll check what the LED state is, and then write the LED state opposite of what it was. Try uploading this. Still having issues with Arduino connecting.
Cody, can you hear me? Sorry.
Yep.
Does it matter for the time?
I think your microphone's glitching, like repeating itself.
Can you hear me better?
No, it's just like repeating your say something and it repeats it over and over again. Feedback loop. Well, while he's now, I'll try to make sure. Okay, this isn't working. I'll try opening this real monitor again just to make sure it's not.
See the chat.
All right. Open team chat. Let's see here. Yep, that could possibly be it. Time sense. Oh, all my variables are equal to the same. Anyways, oh yeah, now the code's working, so it uploaded fine. Perfect. So if we look at the if statement, if current millis minus previous millis is greater than or equal to the interval, we will then make previous millis equal to the current millis. So essentially, it's just checking if the 1,000 seconds or 1,000 milliseconds have passed, we will enter the if loop, and then we will go ahead and set our previous millis for the next check to be what the current time is. That way it won't start this if statement again for another 1,000 milliseconds. And then it will go ahead and invert the LED state, and then it writes the LED state to what was determined up here. So if we look at our Arduino, you can see it's now blinking. But the benefit of this is you could add a whole bunch of code after this, and it wouldn't have to wait that 1,000 milliseconds before it can run. It would check over this, and since nothing needed to be changed, you could then run other functions to keep doing different things to your robot. And then when the loop comes back up, it'll check again. This is what's called non-blocking code. This is just a better practice than what is called blocking code, as it allows for more efficient use of your processor. Anyway, we'll go back to the slides now after. Hopefully the next example will feel better. Share this window. Yep, show how millisavers and code setup. And then now we're going to show just a little autonomous navigation with functions. So I sadly can't show you on a robot since I don't have one with me, but I will show you how the code would look. Go ahead and live code that too. Open up a new Arduino to sketch here. Share that with you. Perfect. So first things first, I want to just show you guys the basic syntax for an if statement. For a function, sorry. So there's a few different ways you can do function. You can do a void function, which does not have what's called a return type. So a void function just means you call a function parameter, and it might take a few parameters inside of the function to act upon, but it won't return a value. So if we do void driveForward, and then we'll put integer distance, or integer time, actually, if you don't have any way of checking distance with this robot currently. So with our robots to drive forward, we have to first set up all of our servo classes. So hashtag include servo. I don't know exactly off the top of my head what it is, but if you never remember, you can always just go into Sketch and include library. Yep. Then up here, servo. 1 second, let me go double check what the pins should be. Just go ahead and copy this from a. So I'll just copy that from the code that normal robot's on. So we just have all of our motors. And then for the setup, yet again, we'll just for the sake of time, copy that from the code, the normal code for the robot. So all of this I'm about to show you can be done inside of the autonomous function inside of the normal code that we give you. I just made its own program just for demonstration purposes. So for driveForward, our robot, we have to set the motor 1.write microseconds. just make sure I know which way is forward. So yep. And we'll do 1350 for these, which is very slowly in reverse. The reason we want these to be very slowly in reverse is because motor 1 and motor 2 are on the left side of the robot, which means they're facing the opposite direction if you look at them straight on as the right side is. So to be having them both drive forward, have to make them go first compared to the other ones, or the ones on the right. And we'll just set that to 1650. Just make sure whatever you do is the same distance away from 1500. So that's 150 away from 1500, and this is 150 away from 1500. You just want to make sure they're both going at the same, both sides are going at the same speed. All right. And then since we have a time variable in here, we will then just for sake of time, we'll just make it have a delay, but a definitely good improvement would just be to implement the millis functions. And then we'll go ahead and set all of our motors off. So I'm trying to copy and paste the code from right here, put it right there. Then we'll just change all of these to 1500. Perfect. Then go ahead. That's all we need for that function. And then up here in the loop, say we want to actually drive forward for a certain amount of time, we would just go drive forward for 2 seconds. And then it would call this code right here. So it would then start, it would take in the 2 as time, and then it would run every line of code in here. So what we'll do is we'll make it have just drive in a circle or drive in a square. So we'll put no delay in here, 10 seconds just for there. And then we'll make another function for turning right. Avoid turn right. And again, have it for time, as we don't have any way of actually checking angle position without actually interfacing using more sensors. So to turn right, we want the left motors going forward and the right motors either stopped or going backwards. So we'll just set these to both be 1350. I'm gonna go check those numbers just to make sure I have those right. Put my reference here. Yes, that is correct. All right. And then yet again, we'll wait a certain time before we turn the motors off. Then what we'll do, have a turn right. And we'll just say for right now, we don't know it off the top of our heads how long it'll take a turn right. We'll just have it turn right for 1 second. Oh, here's a good thing I almost didn't catch. So if you notice in the time, I just had it as a 2. That would only be waiting for 2 milliseconds. So we need to go ahead and make sure we those in milliseconds. All right, you wouldn't even notice it moving if it wasn't. Then we'll delay 10 seconds, and then just essentially repeat this code. So we drive forward for 2 seconds, wait, turn right, drive forward again, wait, turn right, drive forward, turn right. Perfect. So yep, that would make us a perfect square. And if you notice in the loop, it would just keep doing this. Next week, we'll also get a little more into what's called a for and a while loop. That way, instead of having to repeat this code right here for 3 times, you could have it in a loop and say, repeat this set of code 3 times without actually having to write it all out. So another type of function I want to show you guys is what's called a returning function. So instead of having voids, which stands for nothing, no return type, say have one with an integer, and we'll say get sensor data. Then we'll have it take in no parameters. Right now, I don't have any sensors actually interacting with this, but say, actually, we'll make it take in a variable int number. And then to make it return data, you would just put return, and then whatever you want to return. So just for sake of demonstration, we'll make it return a number times 2. This is an example of how you would have a sensor to return data. Now we'll make sure this compiles. And it does not. Aha. Simple mistake on my side. All right, microseconds does not have second capitalized. Just go ahead. Fix all those. Signal. So now we'll verify the code again. Looks like we have another issue still. Oh, yeah, one I missed. That would do it. Oh, it's still going to throw an error. I realized I put 2 S's. That's not what I wanted. All right, perfect. This is another thing about code. A lot of times you make silly mistakes like forgetting to not capitalize a letter or one too many letters. It's just part of the process. Perfect, now compiled. So up here in the loop, we'll also make it call the get sensor data, and we'll output that to serial just so we can actually see it doing that math. And we'll call get sensor data. Make sure we spell it right. Yep. And then we'll just give it the number 4, just for demonstration purposes. We'll also go up here and that. Let's actually enable our serial. 9600. Perfect. And we'll verify the code, make sure everything works. We'll do a report, try uploading it. I won't actually be able to show you guys the movement of the robot, but I will show you. Can't say this after COM 10. Seems to be a common theme for today. I will show you how the math for the robot the math for the returning function will work. File, upload it. Hopefully it'll work this time. It did, perfect. Then we go into serial monitor. Wait for it to connect. Make sure we have 10. Just make sure I'm not connecting to it in any of the other instances. Well, could not open COM 10. Monitor. We'll try plugging it back in. Plugging it back in. There we go. So if you notice, it returned 8. So if we notice, we called get sensor data 4, and then all get sensor data doesn't actually get any data from a sensor. It just takes in the number and multiplies it by 2. In the real world, you'd obviously put the code to interface with the sensor. But that's just a basic idea on how to interact with functions. Functions are very good for things like this, where you want to have a bunch of code that you don't really want to have to write out a bunch of times, because if you just put this into the void for the loop, it would be, well, about 5 times as many lines of code. So this just makes it, when you say write your code, come back next week, and instead of having to decipher what all this does, you can just go up here and you know exactly what it does. You notice that we have driveForward instead of having to decipher what all of those overwrites are doing. So go ahead and go back to 1, the right camera. 2, back to the slides. So yeah, that was just how to drive a simple square using functions. And then that is all I have for today. So anyone have any questions? No
Hey,
questions?
Cody's Prince, I had a quick question here.
Yep.
Hey, before we get our robots built, is there? I'm not sure if you guys have something or not, to where once we have one of our kids write the code, is there a way, or is there a simulator online where they could actually run that code and see it actually get executed?
So with our robots, because they're so custom, we don't have like a purpose-built simulator. I know there is things like Tinkercad and a few other online simulators that will simulate Arduinos. So
Okay.
you could definitely use those for more simple code, but the actual movement of the robot would be kind of hard to simulate.
Okay, you said Tinkercad?
Yeah.
Okay, got it.
It's also good for just making simple electrical schematics too.
Okay, got it. Thank you.
Sorry to jump in. I also wanted to know if you had existing code blocks or sample codes that we could pass along aside from what was already provided in this session.
So there is like a autonomous sample in the main RDL like robot code, but besides that, we don't really have any examples.
All right, no worries. Thank you.
But no problem. Any other questions? Well, if nothing else, that's all I have. You guys are free to go. I'll go ahead and stop the recording now.
Thanks, Cody.
Hey, thanks, Cody.
Thank you.
Yeah, thank you.
Thank you all for coming.